All right, hello. We are going to be going through the Unit H test review. So if you haven't tried and made attempts on it, I would pause this video and try to go through and work some of those problems out. And then when you do come back and watch it through, but I'll share my screen here with you and we will get going through the review. So here on this first problem, this first question here, we're simply drawing the nets for the following shapes. And remember, the nets are if you cut this thing open and try to lay it flat, what it would look like. So here with this pyramid, I'm going to start with this rectangle. And then each side is a triangle. So it might look something like this. Okay, to get that general idea. Here, this prism, we have two triangles and then three different rectangles. So we could draw the rectangles first, put our two triangles on that, and then have a total of three rectangles there. Okay, so if I were to cut this out, fold it up, that's what I would have. Now the next two get a little bit tricky. Maybe some shapes we haven't really seen before. Excuse me. So I'm going to start by drawing this line right here. I'll draw it right there. And then we have 1, 2, 3 triangles, four triangles in the top and 4 triangles at the bottom. So I'm going to draw this triangle and this triangle. And if you want, sometimes you can trace out on this shape the things that you have drawn already. Okay, so then I have these longer sides here, and one might go up with this triangle, and then one would go down with this triangle, and we'd have a matching one on the other side. They're a little bit longer. Okay, that's this triangle, and this front triangle, and this triangle, and this triangle. Now I need to get these two over here. Doesn't really matter where you put them. We'll just kind of put them right here. Okay. So if I were to cut this thing out, fold it up, I would get this. The key thing here is to make sure that we have 4 triangles on top, 4 on bottom, which we do. Now this one is tough. You won't have one this difficult on the test, but we do definitely want to look at it. Okay, so we have 1, 2. If we want to count here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pentagons here that we need to kind of draw out on the shape. So if we draw our first pentagon, okay, then we would draw 1, 2, 3, 4, 5 more onto it. Okay, and again, this can be a little difficult. And these pentagons will likely not really touch each other. And if you don't get it perfectly drawn, that's okay. I know this is a pretty hard shape to be drawing. So I have 6 here, and then I need 6 for the backside. So what we would do here is, because this is going to form kind of a sphere, is we can draw another one over here and just make it touch in one spot here. So if I draw a pentagon here, okay, then another one here. Okay, this is the center of the other one. So then I would draw my 5 pentagons. Oop, I got off. Okay, something like that, and make sure we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We had 12 faces in this, we have 12 faces in that. Okay, number 2 says draw a shape that would produce the figure if rotated about the segment XY. So what shape would I have to draw here that when I spin it, it creates a cylinder? Okay, and that would just be a simple rectangle here. If I spin this around that segment, it will create a rectangle. For a cone, now it could be it could be right side up or upside down, doesn't matter. For a cone, we would just have a right triangle there. Okay, and that could be totally different shapes. And for a sphere, all we're going to do is do a half circle here. Okay, and if I spin that around, it will make a sphere. Describe the types of cross sections that could be created with the following shapes. Okay, so I've got this rectangular square prism here, and we're just going to list out the types of cross sections I could have. Now I could do a horizontal cut, and that would be a square or a rectangle. And you could just kind of draw a line here so that we know you looked at horizontal. We could do a vertical. Okay, vertical in this case would be a rectangle. I said square rectangle because this base could be a square, it could be a rectangle. I'm not sure. I didn't label it well for you. If we did diagonal this way, we could also get a rectangle, but I could also just cut the corner off here. Okay, if I cut this diagonal, cut this corner off, I could get a triangle. And depending on how I cut it, how I angle it, I could get all sorts of different triangles with that. Okay. All right, with this pyramid here, it's a triangular pyramid. If I cut here, I would get a triangle. Again, I could change it little by little and get a triangle. If I cut the corner off, I still get a triangle. So it looks about like every way I would still get a triangle. Even if I did it vertically, I'm still going to get a triangle. Okay, for this one here, this cylinder, if I cut it this way, I'm going to get a circle. Okay, if I cut it this way, that would be a rectangle. Again, we're looking at the cross section. So if I cut a can in half vertically and then look at it, it would show me a rectangle there. If I cut it diagonal, I'd still be getting some rectangles out of that. So there's no way I could get a triangle or anything like that out of it. All right, flip it over. We have number four here. And number 4 says, if you have about a quarter of a gallon, 60 cubic inches of milk, how many paper cups can you fill if the height is 2.5 inches and the radius is 1? Okay, so we have paper cups, paper cone cups. So we have this cone, like so. The radius here is 1 inch and the height is 2.5 inches. And they give me the volume and they want to know how many cups I can actually fill. So I need to find the volume of one of these cups. Okay, so the volume of this, and you can look all of these up on the review in your notebook here on each of the pages. You also have the note card that I strongly suggest you be writing some of these things down on, especially all the formulas. So here, again, when we created the Post-its, that's a good idea there. So volume of a cone, 1/3 pi r squared h. So then for this one, we have 1/3 pi, r we said was 1 squared, and the height is 2.5. So the volume of 1 cup, and I'm going to get a decimal out of this, 1/3 pi r squared times h is 2.62, we'll say, inches squared, cubed. Okay, and I have this many. I have 60. So I'm going to take 60 divided by 2.62, and I'm going to fill, I get 22.9 something. I'm going to fill about 23 cups. That's how many cups I'll be able to fill. So you find the measurement of the volume of 1 cup, divide it by how many volume you have, and that'll be your answer. Okay, here we're going to find surface area and volume of this 3D, the multiple 3D shape here. Okay, so if we surface area and volume, okay, it looks like we have prism. So I'm going to flip over here. The surface area of the prism, and notice it's 2 shapes combined. So I get rid of this triangle actually twice. Okay, so the surface area of this, and these are all the same here. You see those tick marks. So all of these are the same, 3, 3, 3. So we have area of the base, 2 area of the base times perimeter and height. And I think I actually left a measurement off of this. I did. We would need the height of this triangle right here, which this one's kind of hard. So I'm going to give it to you. I don't expect you to know how to find the height of an equilateral triangle. Although I think we could. 2.6. Okay. So this height right here of the triangle is 2.6. Okay. I'll kind of show you how I did that. It's an equilateral triangle. All sides are 3. I want this height right here. So that splits it in half. So this is 1.5. Okay. And then this is a right triangle now. And you could actually use Pythagorean theorem with 3, 1.5, and this height right here. You can use Pythagorean theorem to find out how tall that is. So that's kind of what I did. Okay, so area of the base, 2 area of the base. So you have 2 times a half base times height. So 3 times 2.6 plus the perimeter, which is 3 3s. 3 times 3 times the height of your shape, which is 5. Okay, and then we have the pyramid up here. So that is area of the base. So plus 1/2. 3 times 2.6, base times height divided by 2, plus perimeter, which is 3 times 3, times your slant height here, which is 10.04. Now that's the surface of everything, but remember we talked about having to get rid of these 2 triangles, one for the top and one for the bottom. And you can subtract that out, or you can know I got to get rid of 2 of them. And this right here represents 2 of the bases. So I'm just going to get rid of that portion right there. Okay, I'm going to put all of this in the calculator. So I have 3 times 3 times 5 plus 1/2 3 times 2.6 plus 3 times 3 times 10.04. And that's 139.26. And millimeters squared. Now for volume, there's nothing to get rid of or subtract out. So here we're going to do area of the base, which was 1/2 base times height. Area of the base times the height, so that's 5, plus area of the base up here, which was 1/2 3 times 2.6 times the height of that one, which is 10, but that is the prism, and we need 1/3 of that. 1/3 area of the base times the actual height, not the slant height. So I'll put this in the calculator, 0.5 times 3 times 2.6 times 5 plus 1/3 times 0.5 times 3 times 2.6 times 10. Again, make sure that you can get all of this into the calculator. Millimeters cubed. Make sure you can get that put into the calculator. Make sure you're using parentheses and all of that. Okay, surface area and volume of this shape. Okay, for surface area, we need 2 area of the base. Now this base is a hexagon here. And remember with hexagons, we have 6 triangles here. Okay, so 6 times 1/2. Okay, now I don't have the base of this. All I have, oh yeah, I do right here. It says it's 2. Right there is 2. So the base is 2. So base times, and I need the height. Now the height's actually how we kind of did it up here on this triangle. I need this right here. So this portion is a 1. If I draw that, again, it's an equilateral triangle with 2. Here's this height right here. So this is a 1. So I could use Pythagorean theorem. So 1 squared plus h squared equals 2 squared. 1 squared is 1. H squared, 2 squared is 4. If I subtract the 1, h squared equals 3, and take the square root of that, and we're going to leave it as the square root of 3. So base times height, square root of 3, parentheses, parentheses, parentheses. So that's area of the base plus the perimeter, which would be 6 times 2, because they're 2 and you got 6 of them, times the height, which is 12. Okay, so we got 2 parentheses. I know you can't really see me put it in on the calculator there. 6 parentheses 1/2 parentheses 2 times square root of 3 parentheses 2 3 plus 6 times 2 times 12. And you get 164.78. 164.78 feet squared. Okay, for volume, it would be area of the base, which I have that right here. So 6 times 1/2 times 2 times radical 3 times the height, which is 12. Okay, so 6 times 1/2 times 2 times radical 3 times 12. 124.71. 124.71 feet cubed. Okay. So breaking it down into some 2-dimensional areas that we know. A softball has a diameter of 3.5 inches. how much leather does it take to cover it? How much polyurethane compound does it take to fill it? If you don't know, professional softballs are made of leather on the outside and a polyurethane, which is kind of a plastic compound on the inside. So it has a diameter here of 3.5 inches. So basically what they want for the leather, they want the surface area. And for the polyurethane fill, they want volume. Okay, we just talked about surface area of spheres not too long ago. So for the surface area, it is 4 pi r squared. So 4 pi r. Okay, so all the way across is 3.5. So halfway, if you take 3.5 divided by 2, would be 1.75. So r is 1.75. So 4 pi 1.75 squared. Now, if we do this, we can put it in terms of pi. So that's 4 1.75 squared. So 12.25. Let's see, inches squared. That's how much leather, pi. And then if I take that times pi, you get 38.48. So 38, which is about 38.48 inches squared. That's how much leather it's going to take to cover this polyurethane fill. For volume, it is 4/3 pi r cubed. So in terms of pi, that's 4/3 times 1.75 to the third, 7.15 pi, which is about 22.45 inches cubed for the volume. So that's the polyfill, and then this is the leather. Okay, on the test, it may be a multiple choice or something like that for those problems. Okay, the last page here, number 8, says a tuna can is 1.5 inches tall and 3.375 inches wide. I believe I looked those numbers up so that they were accurate. How much tin is used to make the can? How much tuna can fit in the can? So again, it's area, or it's surface area and volume. So you have this can here, and the can is 1.5 inches tall, and it is 3.375 inches wide. Now for surface area and volume, we need radius. So I'm going to take this 3.375 and divide it in half. So the radius is 1.6875. Okay, so surface area, I need 2 area of the bases. So that's 2 pi r, which is 1.6875 squared, plus circumference. And remember on this, we kind of marked some things out, and we read, or that was the cylinder, that was the cone. I'm sorry, that was the cone. So you get 2 pi r squared plus 2 pi r, which is 1.6875, times the height, which in this case is 1.5. All right, so in terms of pi, it's 2 times 1.6875 squared plus 2 times 1.6875 times 1.5. That's about 10.76 pi, or the whole thing is about 33.80 inches squared. That's how much tin to make the can. That's the surface area. Okay, you're not filling this thing with tin. You're filling it with tuna, which is what I want next. So volume is pi r squared times the height. So in terms of pi, that's 1.6875 squared times 1.5, which is about 4.27 pi. And if I take this times pi, I'm getting 13.42 inches cubed is how much tuna to completely fill that tuna can. Okay. Moving on to number 9. Again, you can always pause or go back and rewatch these if you need to. Find the surface. Oh, if the surface area is 126 units, find the slant height and the volume of this shape. Okay, so this is a pyramid here, and it's a rectangular pyramid. So they give us the surface area is 126. Well, to find the surface area of this thing, it is base, area of the base, which I know is 8 times 2. So 8 times 2 plus 1/2 the perimeter, which I can find, 8 plus 8 plus 2 plus 2. 8 plus 8 plus 2 plus 2 times the slant height, which I don't have, equals 126. Okay, I don't have that slant height there. But I have everything else except that. So I'm going to reduce this and solve it. So 8 times 2 is 12 or 16 plus, and then 8 plus 8 plus 2 plus 2 is 20. 20 times 1/2 is 10. And then I have the L equals 126. I'm going to subtract 16. So you have 10 L equals 126 minus 16 is 110. Divide by 10. And L is 11. So your slant height here is 11. Now, in order to find volume, which is what it wants next, I'm going to take 1/3 area of the base, which is 8 times 2, times the height. And I don't have the height, but what I do have, I can make a right triangle here. This is 4. This is 11. To find the height, I can use the Pythagorean Theorem. So h squared plus 4 squared equals 11 squared. Okay, h squared equals, or sorry, h squared plus 16 equals 11 times 11 is 121. Subtract 16, you get 105, and we'll take the square root of that, the square root of 105. So put it in the calculator here, you get 1/3. 8 times 2 times the square root of 105. And you get about 54.65. I don't have, my label is units. That should have been units squared. This is units cubed. Okay. So sometimes you need to find some other things in your problem. 3 more problems left. Number 10, find surface area and volume of this cylinder. So surface area, we have area of the 2 area of the base. So 2 pi r is 3.75 squared plus the circumference, which is 2 pi r 75 times the height of this thing, which is 11.3. And then volume is pi r squared times your h, 11.3. And on this one, I'm just going to get the decimal. I'm not going to leave pi in it. I think you've seen enough examples of that. So 2 pi r squared plus 2 pi r h. So you get about 354.61 centimeters squared. And for volume, you have pi 3.75 squared times 11.3. 499.22. 499.22 centimeters cubed. Okay, this is some older stuff here. So find the area of this polygon. It has 1, 2, 3, 4, 5, 6, 7 sides. Okay, so given this here. Okay, so we have 7 times 1/2 area of the base, or sorry, area of the triangle. So that's base times height divided by 2. So they give me this thing here. Okay, this triangle. Oop, you can't see this. They give me this triangle, and this is 10, while this is 11.52. So I'm going to use the Pythagorean theorem here to find this height. So this is actually 5. So you get 5 squared plus x squared equals 11.52 squared. So we're going to subtract these two. So x squared equals, if I take 11.52 squared minus 5 squared, I get 107.71, and then take the square root of that. So square root of that answer. And x is about 10.38. So 10.38. So base times height divided by 2. So that's the area of this triangle, and I have 7 of those triangles. So 7 times 1/2 times 10 times 10.38. So you get 363.3 meters squared is the area of that thing. Okay, and they may give you the height, they may not, they may leave it out. Okay, they may just give you this part right here. So if they just give me that part, we'll kind of look at one of these. If they just give me this base here, right here, okay, it has, I need to figure out this angle right here. Okay, this kind of goes back a little ways, but I need to figure out that angle. So I know that this is 5 and 5. I still need to find this. I know it's a right triangle. Okay, I need to find this angle. And there are actually 14 of those angles identical all the way around. If you remember back, in order to find out what the sum of all these angles are, you take 180 n minus 2. Now, n in this case is 7. So 187 minus 2 is 900. So all of these angles add up to 900. Well, I want to know this angle, and there are 14 of those angles around here. So if I divide this by 14, I get 62.629. Sorry, 64.29. Okay, and if you remember back with the right triangles, we had the sine, cosine, and tangent. Okay, this is the adjacent. This is the opposite. So opposite and adjacent is tangent. So I'd use tangent of 64.29 equals opposite over adjacent, which is 5. To solve for x, I'd multiply by 5. And so on my calculator, making sure I'm in degree mode, which I am, I'm going to do 5 tangent of 64.29. I get 10.38, which was exactly what we had right there, 10.38. We just found it a different way. Okay, that's kind of advanced for what I want us to cover. But we have learned all of those things to find that. Okay. Find the perimeter of a triangle with vertices there, and there. Okay, if I have some graph paper, which I don't, okay, so I don't have graph paper, so I'm gonna just kind of do my graph over here. So find the perimeter. So I need to find all the sides. Okay, so A is at -2, 2. That's A. B is at 5, 2. And C is at 0, -3. So this is a triangle I need to find the perimeter of. And we can make a bunch of right triangles as well. But this is a horizontal line. So I went 5 this way and 2 this way. So this side is 7. When looking here, okay, here's my right triangle for this one. Okay, from here to here was 5. And from here to B, this is 2. This is 3 more. That's still 5. So we'd use 5 squared plus 5 squared equals x squared. That's 25 plus 25. That's 50. So that's a square root of 50. So this is 7 plus the square root of 50. Okay, then I need to find this one. So this is 2 and this is 3. So that was 5. And then here, that is 2. So you get 2 squared plus 5 squared equals x squared. So that's 4 plus 25, which is 29. So you get the square root of 29. So we're going to add the square root of 29. So in this case, we have 7 plus the square root of 50 plus the square root of 29. So 19.46 units. Okay, and I have my work over here for you to see. All right, I believe that is all of the review. Okay, if you struggled with any of those, please let me know before you take your test, and I'll help you get those worked out. So this is the last review, the last video lesson. Congrats, you made it through the semester, and I wish you the best of luck in your next math class. Thanks for watching.